Acid and basic properties of amino acids. Separation of plasma proteins by charge typically is done at a pH above the pL of the major proteins. Thus, the change on the proteins is negative in an electric field. The proteins will move towards the positive electrode at a rate determined by the net negative charge. Variations in the mobility pattern are suggestive to certain diseases. Net charge of amino acids at neutral pH. At physiologic pH, amino acids have a negatively charged group and a positively charged group, both attached to the alpha carbon. Note: glutamate, aspartate, histidine, arginine, and lysine have additional protein charges grouped in their side chains. Substances such as amino acids that can act either as an acid or a base are defined as amphoteric and are referred to as ampholytes. Amphoteric electrolytes. The other applications of the Henderson-Hasselbalch equation. The Henderson-Hasselbalch equation can be used to calculate how the pH of a physiologic solution responds to charges in concentration of a weak acid or its responding salt form. For example, in the bicarbonate buffer system, the Henderson-Hasselbalch equation predicts how shifts in the bicarbonate in concentration and CO2 influence pH. The equation is also useful for calculating the abundance of ion forms of acid and other drugs. For example, most drugs are either weak acids or weak bases. Acid drugs release a proton, causing a charged ion to form. A drug passes through membranes more readily if it's uncharged. Thus, for a weak acid such as aspirin, the uncharged HA can perforate through membranes and A- cannot. For a weak base such as microfin, the uncharged form B penetrates through the cell membrane and BH plus does not. Therefore, the effective concentration of the permeable form of each drug as its absorption state is determined by the relative concentration of charged and uncharged form. The ratio between the two forms is determined by the pH at the site of absorption and by the strength of the weak acid or base, which is represented by the pKa of the ionized group. The Henderson-Hasselbalch equation is useful in determining how much drug is found on either side of a membrane that separated two compartments of differ in pH. For example, the stomach 1 to 1.5 and the blood plasma pH 7.4. Concept maps. Students sometimes view biochemistry as a blur of facts and equations to be memorized rather than a body of concepts to be understood. Details provide to enrich understanding of these concepts inevitably turn into directions. What seems to be missing is a roadmap, a guide that provides a student with an initiative understanding of how various topics fit together to make sense. The authors have therefore created a series of biochemical concepts maps to gradually illustrate relationships between ideas presented in a chapter and to show how the information can be grouped or organized. A concept map is thus tool for visualization the connection between concepts. Material is represented in a hierarchical fashion, with the most inclusive, most general concepts to the top of the map, and the more specific, less general concepts arranged beneath. The concept maps ideally function as templates or guides for organizing information so the students can readily find the best ways to integrate new information into knowledge they already possess.